explanation is about a three-phase transformer, which is chapter 8 in electrical trade theory. Firstly, before we even start, let me give a brief explanation what is a three-phase transformer. When we talk about a three-phase transformer, we are talking about three single-phase transformers that are connected together to give us what we call a three-phase transformer. As we know by now, that three-phase transformer has got four configurations. We can have what we call the first configuration, it's a star delta. The second one, we have a delta star. The third one, we've got a delta, and the fourth one, we've got star. But the most common type of a transformer that is used is a delta star. I'm going to explain why. We're going to use this configuration basically to show how we can connect three single-phase transformers to give us what we call a three-phase transformer. Right, we know that a transformer has got the primary and the secondary side. That means that my delta is the primary side and the star is the secondary side. So I've got the primary and the secondary. We normally use IEC symbols to indicate the delta as well as the secondary. But if you look deep into that, you'll see that we normally use three coils. This is the first coil, this is the second coil, and this is the third coil. Meaning that I've got three coils that are arranged in a form of a delta. Even when we go to the secondary side of the transformer, we also have three coils. We call this the star connection, the first coil, my second coil, and my third coil. You see that this is our coils. Now, each coil in practice, we say the coil has the beginning and the end of the coil. Meaning that if I'm talking about the delta, if I'm having A1, which is my beginning, A2, it will end there. If I've got B1, it will be the beginning, B2, it will end there. If I've got C1, it will be the beginning, C2, it will end there. Now, the same thing will happen on the secondary side. I've got the beginning of the coil, it's A1, and I've got A2. I've got B1, I've got B2. I've got C1, and I've got C2. This is what we refer to as the IEC symbols. Now, in practice, when we take a look at a symbol for a single-phase transformer, this is what we have. Now, we are all familiar with this symbol, and we normally draw it for what? For a single-phase transformer. Now, I'm going to draw three single-phase transformers so that I can wire them together to give us what we call a delta star connection. Right. We know that we have the first coil as A1, A2, the second coil B1, B2, the third coil is what? C1, C2. Now in delta, as you can see, that means these two, they give us a point, a common point. We can call that line 1. So therefore, we will have therefore A1 combining with C2, and then we call that line 1. And these two, they come together. We've got A2 and B1. It's A2 and B1. And we say that we've got line 2. And then we combine this B2 combines with C1, B2 combines with C1. So we've got what? We've got line 3. So this is the primary side and it's in delta. We've shown this by connecting what? Single phase transformers to give us delta connection. Now when we go to the star side, star point, which is the star connection, we can see that this is what will be happening. And we normally refer to this as our star point. Now, the star point is very critical. We are going to talk about it a little bit later. For now, I want us to concentrate in terms of how can we put these single phase transformers together to give us what we call a three-phase transformer. As you've seen, we said that this will be A1, we have A2, this will be B1, we have B2, this will be C1, we have C2. Now, as you can see from the symbol, all the twos, they come together to give us a common point, which we refer to it as what? The star point. And this is how it goes. We connect it in star, like that. Sorry for that. Alright, so we know that this is our star connection. Here, A1, we can name it line 1, line 2, and line 3. And we know that three phases got 3 lines. Am I right? Now, on the star side of the transformer, which I've said that this is very important, we know that from the star point of the transformer, we have our neutral as well as the earth. So we are going to talk about this again in chapter 5 and chapter 6. When we are dealing with protection, it's very important. If you look at this, you can see that on the secondary side, our neutral and earth, they are 1 point. Are we clear on that one? So this is very critical. But for now, I want us to focus on this. So it means that if this is my star point, I can get my neutral from there, and I can also get the earth from my star point. Can you see that? This is very important. So we need to understand that there is what we call a symbol. This is our symbol, and this is basically the practical work when we do the connection, where we are putting 3 single phase transformers together to give us what we call a 3-phase transformer. Now, in terms of the calculations, which is what is basically our main core of the day, we know that on transformers, it's very important to identify the connections and how you are going to work out of transformer. If you are going to use transformer ratios, you always have to use phase values to work out your problems. I'm going to pick one problem from the old question paper. This is I'm going to read it out. I'm not going to write the question on the board, but I'm going to be clear as possible. It says that this is a 3-phase transformer. Actually, sorry, it's 3 single-phase transformers with a turns ratio of 50:1. Are delta star connected? Now, it's very important. When we talk about this transformer, we need to write always. You must indicate your primary side, and we must indicate your. Now, when you write down the data, critical, like you see there, I've written the primary and the secondary, I'm writing down the data. You always have to do it that way. Don't just think that you can work out a transformer without writing down the data. You must write down the data. As you can see that here we talk about 3 single-phase transformers which are connected together to give us what we call a 3-phase transformer. We are given the turns ratio is 50:1, meaning that the ratio is 50 on the primary, is 1 on the secondary. Can you see from here? I have already separated my information. I can see what is happening on the primary. I can also see what is happening on the secondary side of my transformer. They say that the primary is what? The primary is delta and the secondary is star. I don't just read it, I write it down. On the primary side, I've got a delta connection. You can even use a symbol or you can draw a symbol. This is a delta. On the secondary, I've got what? I've got a star symbol. Then I can even write it in words. This is my star connection. You don't just let it there. You write them down. But you need to know what is happening to your current as well as the voltage on the primary side as well as on the secondary side of the transformer. Now, this is what will be happening. In the delta side, we say that in delta, always your V line is equals to your V phase. Your I line is equals to square root of 3 I phase. Okay? Now, remember, this information is not going to be given. You as a student, you have to know this by heart. You need to know what is happening in your delta connection as well as what is happening in your star connection. Now, continuing with that, we know that in star, our V line will be equal to square root of 3 V phase. I line is equals to I phase. Basically, that is what will be happening to the connection. Remember, this is the information that you have to know yourself. They say that further, the supply voltage is 11 kilovolts. The supply is always on the primary side. You cannot have a supply on the secondary side. It's only a load that is on the secondary side. Here we are talking about the supply, meaning that my supply is on the primary side. It's 11 kilovolts. Now, be careful. When we talk about the voltage, you see there, we talk about the line voltage and the phase voltage. And in our question, they are not mentioning whether we have a line or a phase. Every time in a three-phase transformer, if they are not saying a line or a phase, you always take the value as the line value. So in other words, we are given a line value, V line 1 as equals to how much? 11 kilovolts. This is our primary voltage. And the secondary phase current, you see here, the examiner was specific to mention what type of current is given. We are given here our phase current. So we know that I phase 2 is equals to 450 amps. This is our phase current. We've got the line current, we've got the line voltage, and the phase voltage. Now be careful when you work out your transformer. You see, the primary side I'm using 1. The secondary side I'm using 2. Now, if I'm given the line value, I have to indicate that I'm given a line value. I'm not just writing voltage. Can you see that? Or V. I'm indicating that the voltage given to me is a line voltage. On the secondary side, you see there, critical. I'm given what? The phase current. So I have indicated that this is a phase current because my phase current can be different from my line current. So I must always indicate whether I'm having a phase or a line so that I can be able to work out my transformer. Okay? Now, the first question, it says that number 1, they say that they want me to find the secondary line voltage. You see, this is why it's important to understand that when you work on a three-phase transformer, you must always use phase values, especially if you are using transformer ratios. I'm sure by now we know what is a transformer ratio. So, if you look at this, we are going to say, okay, fine, I know that I have to use V phase 1 over V phase 2. That will be equals to the ratio. Now, very important, ratio doesn't mean we are talking about the number of terms. A ratio is different from number of terms. Are we clear on that one? We need to be clear on that one. So we have a ratio there. So I know that I have to find my V phase. Now, I'm looking for what? For V phase 2. This is what the question wants. They want us to find the secondary phase line voltage, but we cannot find the line before we find our phase. This is very important. Now, everything needs to be converted to phase. If we look on the primary side, I'm given my line voltage. So what I need to do is to change this line to a phase. Then I go back to the type of the connection. If you look at my connection, it's a delta, and in delta I'm told that my line is equals to my phase. So I'm going to work it out here. V line 1 is equals to V phase 1. So therefore, my V phase 1 would be equals to what? Would be equals to 11 kilovolts. Meaning that I can be able to find my V phase 2. So I'm going to say that, therefore, V phase 2 is equals to, before we do that, I want us to go through step by step. So we are going to say V phase 1 over V phase 2 is equals to ratio, which is 50 over 1. So what we need to do, we need to do a cross multiplication in order to get our V phase 2. So cross multiplication, we've got 1 multiplied by V phase 1 is equals to 50 multiplied by V phase 2. But we are looking for what? For V phase 2. So therefore, this gives us V phase 2 being equals to 1 multiplied by V phase 1 divided by 50. And that will be 1 multiplied by 11 kilovolts. So it's going to be 11 multiplied by 10 to the power 3 divided by